this question, we find the empirical formula for the compound that contains 42.05 grams of nitrogen and 95.95 grams of oxygen. So once again, this evidence that we are working with is referred to as empirical evidence. Evidence that we can obtain from some direct analysis. And often it's possible to get the percentage of nitrogen or the mass of nitrogen and the percentage of oxygen or the mass of oxygen. It doesn't make a difference in how you go about calculating the empirical formula, because whether you get percentages or masses, the relative amount in moles would remain the same when you follow these steps. And here's what you do. You take, in this case, the absolute mass of nitrogen in the molecule and the absolute mass of oxygen in the molecule, dividing each by the relative atomic mass, here of nitrogen and here of oxygen. And you can see the approximate ratio that you get is 3 to 6. And that reduces to the smallest possible whole number ratio of 1 to 2. And this smallest possible whole number ratio is the very thing that we refer to as the empirical formula. The empirical formula here for this molecule is NO2. NO2 is a familiar molecule. Is that actually the molecule that we have? It could be. Sometimes the empirical formula is the molecular formula. And the only way to know this is to get the molecular mass, the relative molecular mass, what's also referred to as the molar mass of the molecule. And if the molar mass turns out to be 1 times 14, which is 14, plus 16 times 2, which is 32, approximately 46, then the empirical formula is the same as the molecular formula.